Welcome back. Today, let's try to understand the basics of the solid principles in general. Later, we'll see specific to Golang. So, the solid principles are like a five principles. When we follow this, like a, creating and maintaining a more flexible and scalable software. These principles were introduced by Robert C. Martin and are widely adopted by the object-oriented programming and software design. So we'll talk about each principle. First, actually, S stands for like a single responsibility principle. What is this? Is a class should have only one reason to change. What it means is that the 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 class only has only one responsibility. What is the importance of this is like by this single responsibility, classes become more focused and less prone to unexpected changes. This leads to better maintainability and a clear understanding of the code. And second is O. O stands for open close principle. So open close principle says that software entities should be open for extension but closed for the modification. So this encourages to use the inheritance and interfaces to allow for adding new functionality without altering the existing code. So we'll see like in Golang how we can achieve this. And importance of this is like a open close principle promotes the code extensibility without modifying existing code. This actually reduces the risk of introducing bugs in well established components all are already the code which is already working fine. Third one is L. L stands for Liskew's substitution principle. So this principle says that subtypes must be substitutable for their base types without altering the correctness of the program. Uh, the subclass should be replaceable with the objects of the subclass without affecting the program's functionality. So we'll see like how we can do this in Golang in some time. So this Lisu substitution principle ensures that inheritance is used appropriately and preventing the unexpected behavior when substituting objects of a different type. And I stands for interface segregation principle. The clients should not be forced to depend on interfaces if they are not using it. This principle encourages create specific client focused interfaces rather than giving large or generic purpose ones. So this interface segregation principle promotes a more modular and maintainable design by avoiding unnecessary dependencies between clients and the interfaces. It also prevents the classes from being burdened with methods they don't want to use it. And last one is D. D stands for dependency inversion principle. So this principle says that high-level module should not depend on low-level modules. Both should depend on abstractions. Abstractions should not depend on details. Details should depend on the abstractions only. This principle encourages to use the interfaces and abstract classes to decouple high-level and low-level components. So importance of dependency inversion principle is reduces the code coupling and making it easier to replace or extend the components without affecting the entire system. It also facilitates testing and promotes a more modular and flexible architecture. We'll talk about why solid principles are important. Maintainability. Solid principles promote code that is easier to understand and modify. Each principle contribute to reducing the complexity of the code base, making maintenance tasks more straightforward. Flexibility and extensibility. By adhering these principles like the open close principle, developers can extend the functionality of the system without modifying existing code. This enhances the software flexibility and adaptability uh, by any new requirements or any changing the requirements. And readability and understandability. Yes, code when you write the code by following the solid principles, it will be more readable and understandable. Each class and a module has a clear and specific purpose. It is really making it easier for developer to grasp and the design and the logic, and also newcomers can read and understand the code very easily. And testability, these principles contribute to creating code that is more modular and decoupled. This makes it easier to write the unit test cases and ensure that changes on one part of the system doesn't have like unintended consequences on their parts, meaning that the already verified code should not create any problems with the newly introducing code. Scalability, scalable principles provide a foundation for building scalable systems. As the code base grows, this principle helps maintain a clean and organized architecture, preventing the system from becoming unwieldy. So these are about theoretical part of the solid principles and why we need solid principles. We'll talk practically each principle with the Golang, like by implementing it. Okay, thank you.